This is AS2 Physics 2, January 06, and this is a question 4. And this might apply to some of the sound questions, but again, you might have to use this to determine a frequency of a wave, so that's why I put it in here. A cathode ray oscilloscope CRO may be used to measure the frequency of a pure note emitted by a small loudspeaker connected to a signal generator. State what other piece of equipment is required to enable the note to be displayed on the cathode ray oscilloscope. So to pick up your note, you need a microphone. And then that converts your sound signal into an electrical signal, and then it's displayed in the CRO. Figure 4.1 is a diagram of the graticule of the CRO, the graticule just being the screen. On figure 4.1, sketch the trace you would expect to obtain in the CRO when all adjustments have been made. So it says it's the frequency of a pure note, and therefore we're just going to draw a sine wave and just make it nice and evenly spaced, because if it is a pure note, it should have a constant frequency and a constant amplitude. And so just draw a nice sine wave, and it doesn't really matter what size it is, they'll mark it right, as long as it is evenly spaced and has a constant amplitude. The next part of the question, state the measurements you would take and any other information you would need. State how you would process the data in order to obtain a value for the frequency of the note. State appropriate units for any quantities you use in the processing. So what you need to do is measure the time period of the wave by counting how many large squares for one complete wavelength. Secondly, you have to convert the number of large squares to a time by using the time-based setting. And lastly then, calculate the frequency f using 1/t, and it has to be in seconds, and that's important because very often your time-based settings in milliseconds or microseconds. State a practical procedure you would use to ensure that the frequency value determined from your CRO measurement is accurate. You could use many wavelengths to calculate a total time period and then find an average by dividing by the number of waves. And the other thing that you could do is you could check that your time base is in your calibrated position, which is one of the buttons down beneath. It's like a volume control or a control. It has to be right round to the left, and that's in the calibrated position.